curious minds, and welcome back to Grow English Mastery Podcast. I'm Scarlett, and I'm so excited to embark on another learning adventure with you today. Before we journey into the cosmos, let's set our learning mission for this episode. First, we will explore the life of Nobel Prize-winning physicist Kip Thorne and his incredible work with LIGO. Second, we will learn 10 essential vocabulary words to help you discuss the universe and scientific discoveries. And finally, we will review key grammar points, like the passive voice and different tenses, to describe these amazing achievements. So, with our mission set, let's begin. Have you ever looked up at the night sky and wondered about the deepest mysteries of the universe? About exploding stars, black holes, and events so powerful they shake the very fabric of space and time? Today, we're going to meet a scientist whose life's work has given us a new way to observe these cosmic events. We're diving into the story of Kip Thorne, an American astrophysicist whose pioneering efforts helped us detect something Albert Einstein predicted a century ago: gravitational waves. This is a story about incredible scientific vision, decades of persistence, and opening a new window onto the universe. So, let's get ready to journey to the edges of space and time with the story of Kip Thorne. Kip Stephen Thorne was born in Logan, Utah, in the USA, in 1940. From a young age, he was fascinated by science. One story tells that his interest in science sparked after attending a lecture about the solar system when he was just a boy. This early curiosity set him on a path to becoming one of the world's leading experts on Albert Einstein's theory of general relativity. He studied physics at the California Institute of Technology, Caltech, and received his PhD from Princeton University, where he was mentored by another famous physicist, John Wheeler, who actually coined the term black hole. Professor Thorne spent most of his career as a professor at Caltech, where he inspired generations of students and researchers. His work focused on understanding gravity, black holes, wormholes, theoretical tunnels through spacetime, and, crucially, gravitational waves. Now, what are gravitational waves? To understand this, we need to briefly think about Albert Einstein. Over 100 years ago, Einstein came up with his theory of general relativity. One of the core ideas of this theory is that gravity isn't just a force pulling things together. It's actually a curving or warping of space and time, which Einstein called spacetime, caused by mass and energy. Imagine placing a bowling ball on a trampoline. It creates a dip, a curve in the trampoline's surface. Einstein said massive objects do something similar to spacetime. From this theory, Einstein predicted that when massive objects accelerate or move violently, like two black holes orbiting each other and merging, or a star exploding, they would create ripples in the fabric of spacetime itself. These ripples, traveling outward from the source at the speed of light, are gravitational waves. Think of dropping a pebble into a still pond. The ripples spread out across the surface of the water. Gravitational waves are like ripples in spacetime. For decades, gravitational waves were just a theoretical prediction. They were incredibly difficult to detect because their effects are unimaginably tiny by the time they reach Earth. Imagine a ripple from a cosmic event, millions or billions of light-years away passing through you right now. It would stretch and squeeze spacetime by an amount far smaller than the width of an atom. Detecting such a minuscule change seemed almost impossible. But Kip Thorne was one of the key scientists who believed it could be done. He, along with Rainer Weiss from MIT and Ronald Drever, also from Caltech, originally from Scotland, became the architects and driving force behind a colossal experiment designed to do just that. This project is called LIGO, which stands for the Laser Interferometer Gravitational Wave Observatory. What is LIGO? It's an amazing feat of engineering. It consists of two identical observatories located over 30 kilometers apart in the United States, one in Hanford, Washington, and the other in Livingston, Louisiana. Each observatory is L-shaped, with two vacuum tunnels, each 4 kilometers long, extending out at a right angle. Inside these tunnels, laser beams are split and sent down each arm. Mirrors at the ends reflect the laser beams back. Normally, these beams are set up to cancel each other out when they recombine. However, if a gravitational wave passes through Earth, it will minutely stretch one arm of LIGO and squeeze the other, then vice versa. This tiny change in the arm lengths, even by a fraction of the diameter of a proton, would disturb the laser beams just enough so they no longer perfectly cancel out. This disturbance would create a detectable signal. It's an incredibly sensitive instrument. Kip Thorne was instrumental in developing the theoretical understanding and the data analysis techniques needed to identify a gravitational wave signal from all the noise. For many years, LIGO searched, but no gravitational waves were definitively detected. It required enormous patience, funding, and the hard work of hundreds of scientists and engineers. Then, on September 14, 2015, something historic happened. Both LIGO detectors registered a clear signal. After months of careful checking and rechecking, the LIGO team announced to the world in February 2016 that they had directly detected gravitational waves for the first time. The signal came from the merger of two black holes, which had happened about 1.3 billion years ago. This discovery was a triumph. It confirmed a major prediction of Einstein's theory and opened a completely new way to observe the universe. Before this, almost all our knowledge of the cosmos came from electromagnetic radiation, like visible light, radio waves, X-rays. Gravitational waves are different. They are disturbances in space-time itself. They allow us to hear the universe in a new way, to detect events that are invisible to traditional telescopes, like the collision of black holes or neutron stars. For their crucial contributions to LIGO and the first detection of gravitational waves, Kip Thorne, along with Rainer Weiss and Barry Barish, who became the principal investigator of LIGO in 1994 and saw it through construction and operation, was awarded the Nobel Prize in Physics in 2017. It was a recognition of decades of visionary work. Now, let's discuss some grammar that's helpful when talking about people like Kip Thorne and scientific endeavors. First, the past simple tense, which we use for completed actions in the past, is essential for biographies and historical events. Kip Thorne was born in 1940. He studied physics at Caltech. Einstein predicted gravitational waves in his theory of general relativity. The LIGO team announced the first detection in 2016. Thorne, Weiss, and Barish received the Nobel Prize in 2017. Try forming sentences about important moments in history or a person's life using the past simple. Second, the present simple tense. We use this for general truths, scientific facts, or to describe how something works. Gravitational waves are ripples in spacetime. LIGO uses lasers to detect these waves. Massive objects create curves in spacetime. These waves travel at the speed of light. Astrophysicists study the universe. Think about scientific facts you know and try to state them using the present simple. Third, the passive voice. This is very common in scientific contexts, especially when the action or the result is more important than who performed it. Gravitational waves were predicted by Einstein. The LIGO detectors were built in Washington and Louisiana. The signal was detected on September 14, 2015. The data is analyzed by scientists. A new window to the universe has been opened. Notice how the passive voice helps to maintain an objective tone. Fourth, modal verbs like can, could, may, might, and will are used to express ability, possibility, prediction, or potential. Gravitational waves can tell us about black hole mergers. LIGO could detect even more exotic cosmic events in the future. This discovery will change our understanding of the universe. Future observations may reveal surprises. Scientists might find evidence for new theories. Let's look at some effective ways to practice your English using today's topic. For listening, search for videos or short documentaries about Kip Thorne, LIGO, or gravitational waves. Many science communicators create excellent content for a general audience. Listen for the main ideas and any new vocabulary. Websites of organizations like NASA or ESA, European Space Agency, often have accessible audio-visual material. For speaking, try to explain what gravitational waves are to a friend or family member in simple English. Imagine you are explaining LIGO. What were the main challenges? What was so important about the discovery? Practicing explaining concepts helps solidify your understanding and your language skills. For reading, look for simplified articles about astronomy or physics. Websites like NASA Spaceplace or New Scientist, some articles may be more advanced, so look for introductory ones, can be good resources. As you read, note down new words and phrases. For writing, write a short summary of Kip Thorne's contribution to science. Or, write a few sentences about what you find most fascinating about the universe or space exploration. This helps you to organize your thoughts and practice sentence construction. Now, let's delve deeper into 10 key vocabulary words related to our discussion today. Astrophysicist noun, a scientist who studies the physical and chemical properties of celestial bodies and the universe. Spelling, Astrophysics. Kip Thorne is a renowned astrophysicist known for his work on gravitational waves. Astrophysicists use telescopes and other instruments to observe distant galaxies. Becoming an astrophysicist requires a strong background in physics and mathematics. Gravitational wave. Noun phrase. A ripple in the fabric of spacetime caused by violent and energetic processes in the universe. Spelling Gravitationalwave. The detection of gravitational waves confirmed a key part of Einstein's theory. Merging black holes are a powerful source of gravitational waves. LIGO was built to detect these faint gravitational waves. Black hole. Noun phrase. A region of spacetime where gravity is so strong that nothing, not even light, can escape. Spelling BLACKHOLE. Kip Thorne is an expert on black holes and their properties. The first gravitational waves detected came from two merging black holes. The concept of a black hole is one of an object with incredibly dense mass in a tiny space. Universe. Noun. All of space and time and their contents, including planets, stars, galaxies, and all other forms of matter and energy. Spelling UNIVERSE. Gravitational waves provide a new way to study the universe. The universe is vast and full of mysteries yet to be discovered. Scientists are constantly learning more about the origin and evolution of the universe. Theory. Noun. A supposition or a system of ideas intended to explain something, especially one based on general principles independent of the thing to be explained. Spelling THEORY. Einstein's theory of general relativity predicted the existence of gravitational waves. A scientific theory is well tested and supported by evidence. New discoveries can sometimes lead to revisions of existing theories. Experiment. Noun. A scientific procedure undertaken to make a discovery, test a hypothesis, or demonstrate a known fact. Spelling EXPERIMENT. The LIGO project is a massive experiment designed to detect gravitational waves. Scientists conduct experiments to gather data and test their ideas. The results of the experiment were published in a leading scientific journal. Detect. Verb. To discover or identify the presence or existence of something. Spelling DETECT. LIGO was finally able to detect gravitational waves in 2015. It is very difficult to detect these tiny ripples in spacetime. New instruments are being developed to detect even fainter signals from space. Collaboration. Noun. The action of working with someone or a group of people to produce or create something. Spelling COLABORATION. The LIGO project is a huge international collaboration involving hundreds of scientists. Successful scientific breakthroughs often result from collaboration between experts in different fields. Kip Thorne emphasized the importance of collaboration in achieving LIGO's goals. Breakthrough. Noun. A sudden, dramatic, and important discovery or development. Spelling BREAKTHROUGH. The first detection of gravitational waves was a major scientific breakthrough. This breakthrough opened a new era in astronomy. Researchers are hoping for a breakthrough in understanding dark matter. Nobel Prize noun phrase, one of a set of 6 annual international awards granted in several categories by Swedish and Norwegian institutions in recognition of academic, cultural, or scientific advances. Spelling: Nobel Prize. Kip Thorne, Rainer Weiss, and Barry Barish shared the Nobel Prize in Physics in 2017. Winning a Nobel Prize is one of the highest honors a scientist can receive. The Nobel Prize highlights discoveries that have greatly benefited humanity. Practice using these words in your own sentences. This will help you remember them and use them confidently. Let's look at some more grammar examples, focusing on Kip Thorne and his work to reinforce these structures. Describing Kip Thorne and his early career. He became interested in science at a young age. He has dedicated his life to understanding Einstein's theories. The theories he worked on were very complex. Explaining gravitational waves and LIGO's function. Gravitational waves are produced by massive accelerating objects. LIGO's arms must be incredibly stable to detect such small changes. If a gravitational wave passes, the length of the arms changes slightly. The laser light is reflected by mirrors at the end of each arm. Discussing the impact of the discovery. This discovery has provided scientists with a new tool. More gravitational wave events have been detected since 2015. Scientists will be able to study the universe in new ways. Our understanding of the cosmos is being transformed. So, as we come to the end of our session, let's recap the main points about Kip Thorne and his revolutionary work. First, we learned about Kip Thorne, the American astrophysicist whose theoretical work and leadership were crucial for the LIGO project and the detection of gravitational waves. Second, we explored what gravitational waves are, ripples in spacetime predicted by Einstein, and how the incredibly sensitive LIGO detectors were designed to find them. Third, we understood the significance of the first detection in 2015, which confirmed Einstein's prediction, earned Thorne, Weiss, and Barish the Nobel Prize in 2017, and opened a new field of gravitational wave astronomy. Fourth, we reviewed key grammar points like the past simple for biographies, present simple for scientific facts, the passive voice for describing discoveries, and modal verbs for discussing potential and impact. We also expanded our vocabulary with terms related to astrophysics and discovery. And finally, we drew inspiration from Thorne's decades-long perseverance, the power of scientific collaboration, and the way such discoveries expand our understanding and appreciation of the universe. I truly hope this lesson has not only helped your English, but also sparked your curiosity about the amazing universe we live in. Remember to approach your language learning with the same spirit of inquiry and persistence that scientists like Kip Thorne bring to their work. Don't be afraid to explore new topics in English, even if they seem challenging at first. Celebrate your progress, and keep asking questions. Thank you so much for joining me today on Grow English Mastery. What did you find most interesting about Kip Thorne's story or the science of gravitational waves? Are there any other scientific topics or inspiring figures you'd like us to cover? Please share your thoughts, ideas, and any questions in the comments section below. I always look forward to hearing from you. If you enjoyed this video and found it useful, please give it a thumbs up. It really helps our channel to grow. And if you haven't subscribed to Grow English Mastery yet, please do so and click the notification bell so you don't miss out on our future English lessons. Sharing this video with friends or anyone interested in science and English would also be fantastic. Keep learning, keep exploring, and never lose your sense of wonder. The universe is full of mysteries, and your English journey is full of possibilities. Until next time, take care and happy learning. Bye for now.